We will try the nines complement procedure now on several other problems. First, using the textbook algorithm from 12,250, I'm going to subtract 5,375. 5 is greater than 0, so I have to borrow 1 from that 5, make it a 4, and this becomes 10. 7 is greater than 4, so I have to borrow 1 from that. That becomes a 1, and this becomes 14. 3 is greater than 1, so I have to borrow 1 from that number. 2, it becomes a 1, and this becomes an 11. 5 is greater than 1, so I have to borrow 1 from that 1. That becomes a 0, and this becomes an 11. So I had to modify the minuend extensively. It now reads 0, 11, 11, 14, 10. So I have it in a form where I can now do the subtractions. 5 from 10 is 5. 7 from 14 is 7. 3 from 11 is 8. 5 from 11 is 6. 0 from 0 is 0. So my difference is 6,875. How many operations did I do? Using the textbook algorithm. Number modifications 1, 2, 3, 4, 5, 6, 7, 8. And then I did 1, 2, 3, 4 hard subtractions. Requires 12 operations to get that answer. Now we'll do it by the nines complement procedure. In the nines complement procedure, if the minuend digits, 5 in this case, is greater than the subtrahend digits, 4 in this case, we have to add a leading 0. Otherwise the nines complement procedure will not work. The number added to 0 that equals 9 is 9. The number added to 5 that will equal 9 is 4. The number added to 3 that will equal 9 is 6. The number added to 7 that will equal 9 is 2. The number added to 5 will equal 9 is 4. So I have the nines complement of the subtrahend. Now I'm going to proceed to add. 4 and 0 is 4. 2 and 5 is 7. 6 and 2 is 8. 4 and 2 is 6. 9 and 1 is 10. So I get a carry into the 100,000ths place. The final step in the nines complement procedure is to take that 1, leftmost digit, it's always going to be a 1, add it to the rightmost digit, in this case 4, and I get a 5. So I get 6875. That is the correct difference. I only converted the subtrahend to its nines complement, and then I did 1, 2, 3, 4, 5 easy additions. Does this apply? Does the nines complement procedure work for decimal fractions? What if I put a decimal point there, there, and there? I'll write the minuend again, this time 12.250. Then I'll take the subtrahend and write the nines complement of it. So it'll be 9.4 decimal point 624. Then I will add it to the minuend. I get 106.874. Then when I add this 1, the leftmost digit, to the rightmost digit, I get 6.875. The same as it would be here, 6.875. In the decimal fractions, the numbers do not change. The only thing is we have a decimal point now. So it works for integer numbers. It works for decimal fractions. Does it work for mixed numbers? This number, translated into a mixed number, 12.250, is 12 1/4. This number, when translated into a mixed number, is 5 and 3/8. 5.375 translate to 5 and 3/8. From 12 and 1/4, I want to subtract 5 and 3/8. But I'm going to use the 9's complement procedure. So I have to find the 9's complement of this subtrahend, 5 and 3/8. I'm going to add 3 to that 5. I get an 8. And then I'm going to add a fraction to make this 8 over 8. So I need a 5/8. 5 added to that 3 gives me 8 over 8. And so my number down here will be 8 and 8/8 is another way of writing 9. So this is the 9's complement of this subtrahend. So I'm going to proceed to add it to the minuend. 2/8 is another way of writing 1 over 4. So now I can proceed to add. 12 and 3 is 15. 2 and 5 is 7, so I get 15 and 7/8. My last step in the 9 complement procedure is take this leftmost digit, it will always be a 1, add it to the rightmost digit, 5 in this case, I get a 6. 6 and 7/8. So 12 and 1/4 minus 5 and 3/8 is equal to 6 and 7/8. The algorithm is valid for all numbers. Integer subtraction, decimal fraction, and mixed numbers. The special case that we learned in clip 1 and clip 2 will allow a student in the first grade who are learning addition for the first time, when they reach the level of skill where they can add 2 basic numbers that sum to 9, they can be taught to do subtraction by addition. And they can verify. They don't have to memorize the facts in the subtraction table. They can verify it using the special case algorithm. And the general case algorithm is valid for all numbers. And where did it come from? This handheld calculator, and every handheld calculator on the planet, and every computer on the planet does subtraction by addition and has done it that way since their inception. What method should be taught in elementary school? Both. Textbook algorithm and subtraction by addition using the 9's complement procedure.